Hello guys, welcome back to my YouTube channel. So today we are going to solve one more important problem related to linked list, that is remove nth node from the end of list. It is a very easy problem, so I hope that by the end of this video you will be able to understand this code. And yeah, so without any delay, let's get started. So in this problem we have given the head of a linked list and we have to remove the nth node from the end of a list. Okay, so we have to remove the nth node from the end of list, and then in the end we have to return its head. So this is example 1. So in this example 1 we have these nodes 1 2 3 4 5. Okay, so this is our head and n is given as 2. So from the end 1 2, so we are going to remove this 4. Okay, so our output is 1 2 3 5. Okay, so now just get started here. Okay, so first of all we are going to check if there is only a single element in the our linked list. Okay, so if there is only one single element, then you can see here constant n is always greater than equal to 1 and less than equal to size. So if there is only single element in the linked list, then we are going to just return null. Okay, so write like this: if head dot next is equal to null. So if there is only one single element in the list, then we are just going to return null. Okay, okay, and here also you can say you can see that size is also always greater than equal to 1 and less than equal to 30. So there is always one element in the linked list. Okay, so we can write this condition like if head is equal to null, then return null. So no, so here it is given as there is one size is always greater than equal to 1 and less than equal to 30. So if there is one element, then we are going to return null because of this condition. Okay, so this is the first case. And after that just point one cur list node cur to the head of the linked list. Okay, so list node cur is equal to head, and create one variable of int size is equal to 0. So now we are going to get the size of this linked list. So for that we are going to write one while loop. While cur is not equal to null, so if our cur is not equal to null, then in that case we are going to increment size by plus plus, and also cur will point to the next element. Cur is equal to cur dot next. So in this step we are going to get the size of the linked list. Okay, now after that there is one more base condition, like if our n is equal to size. Okay, so let's say in any case if the n is given as 5. So let's say in this example n is given as 5. Okay, and the size of this list is also 5. Okay, so in that case since we are removing the nth node from the end, so that's mean we are going to remove this one. Okay, so in that case we are going to return the elements from this position 2 3 4 5. Okay, so if that's the case, then we are just going to return, if n is equal to size, we are going to return head dot next, because we are deleting the fifth element from the end. If n is equal to 5 and the size is also 5, then we are going to remove the end first element only. So in that case we are going to return head dot next. Okay, so now after that write one index which we are searching, like index to search. So let's say we are searching size minus n, write it like this. So total size of the linked list 5 and we are searching this 2. Okay, so size 5 minus 2 3. So we are searching this index like this one 3. So this is the index that we are searching. So in this case this 3. Now after that initialize one loop, int I is equal to, first declare I is equal to 1, then after that uh, list node prev node point it to the head of the linked list. Okay, and after that just run one while loop while I is less than index to search. Index to search. Okay, so now just point priv node, just update the value of priv node to priv node dot next. Okay, and increment I. Okay, so now here as you can see, this is index to search, so size minus n. So in this case size is 5 and n value is 2, so we are searching the index number 3 here. Okay, and here we initialize I is equal to 1 and list node priv node is equal to head, so priv node is given as head, that is this one. Okay, so now while I is less than equal to less than index to search, okay, index to search is 3, so I, that is 1, is less than equal to 3, then priv node is incrementing by 1. Okay, so when so in this case when we are going to run the priv node, so priv node reaches this position, 3 position. Okay, priv node reaches this position. So first case I1 is less than 3, so our priv node was here. Okay, so now priv node is going to this position, then 2 is less than 3, yes, so priv node going to this position, then 3 is less than 3, no, so this was the end. Okay, so priv node is here. So now we are going to update priv node, that is this position, priv node dot next, that is this node 3 next is priv node dot next. Okay, so now what we did, we break the connection here from here 3 to 4, 4 to 5. We just update the connection, that is priv node dot next is directly pointing to this 5 now. Priv node dot next, that is this is priv node, its next is directly pointing to 5 now in this step. Okay, and in the end we are just going to return the head of our linked list. Okay, so now let me try to run this code. So all the test cases has been accepted here. Okay, so let me submit it. Okay, so our solution is accepted and it beats 100% of users with Java. So I hope that you guys are able to understand this code, and if you like this video, then please share and subscribe my YouTube channel. Till then, keep coding and keep practicing. Bye bye, thank you.